So for our first one, we just want to find the rate of change of E of t. E of t is just a rate of the cars entering the parking lot, but we want the rate of change of E of t, so that's just E prime of 7, since it's at 7. That's pretty straightforward. Your calculator will tell you that that value is 6.164924 or something like that. And they wanted units. Well, E of t was already cars per hour. We differentiate with respect to time, which was in terms of hours, so this should be cars per hour squared. Good?
Good.
Great. And I didn't say to. That's all it said to do. Okay. Part B, how many cars enter the lot from 0 to 12? That should be easy also. That's just an integral from 0 to 12 of the rate at which they enter. Don't need to care about how many cars leave. It's just 0 to 12 of E of t. And that came out to be, to the nearest whole number, 520 cars. Easy enough for A and B? Nope.
Agree.
Yeah, one there, one there, one there. 3 points for parts A and B. Then a trapezoidal sum for 2 to 12, and then they want us to explain what that means, of L of t. So if we're going to go from 2 to 12, that means that we've got to start at t equals 2 here and go to t equals 12, trapezoidal sum with unequal subintervals, right? 2 to 5 is 3, 5 to 9 is 4, then 2, then 1 unit. So we just got to break it down into each one. Should be, what do we have, 15 and 40. Divided by 2 times the length of the subinterval, which was 3. Add the next one, 40 and 24. We're going to multiply that one by 4. Next one is 24 and 68. We'll multiply that one by 2. And the last one is 68 and 18, and multiply that one by 1. And add all of that up together, and you get 345.5. And it asks us, what does that integral mean? That's just, since it's an integral of the rate at which they're leaving, that's the number of cars that leave between t equals 2 and t equals 12, which t equals 2 would be 7 a.m. to 5 p.m. based on t equals 0 being 5 a.m. Easy enough for part C, I think. This is a pretty easy question. They gave you 1 for the setup, 1 for the number, 1 for the explanation. And then for part D, I believe it said that from 0 to 6 hours, they charged $5 per car, and from 6 to 12 hours, they charged $8. They want to know how much money. So just 5 times the integral from 0 to 6 of the number of cars that enter. And then I think it was it 8? I think it was 8 for the other one. 6 to 12 of E of t dt. And you just evaluate that out, and you end up getting, and I think they said to the nearest dollar again, so $3,530. And that was worth 3 points somehow also. 1 point for having E of t inside of each one of those, 1 point for all the limits and the constants, and then 1 point for the final answer. Hopefully everyone was good with that one. That one was exceptionally easy. Yes?
Great.
Great. All right. And then we got the problem with the laser. So we got a laser. It tells us a laser is a device that produces a beam of light. Very exciting. So they've made this design using the laser. The position of the laser is x of t, y of t. It starts at 0, 0 at t equals 0. Does this whole design in 3.1 seconds. The dx dt and the dy dt are given to us. we want to find the speed of the laser at t equals 3. So how do we find speed? That should be the absolute value of the velocity vector. The velocity vector is just this 3 cosine t squared, comma 4 cosine 2.5t. And to find the absolute value of that, we just use the square root of dx dt at 3 squared plus dy dt at 3 squared. And that should give us our speed. And that came out to be 3.065. Everybody good with that?
Yes.
Great. You get 1 point for that. Part B, we want the total distance traveled. So that's the integral of the speed. So that will just be the integral, and it's from t equals 1 to t equals 3. So the integral of dx dt squared plus dy dt squared dt. And your calculator, once again, will tell you that's 7.090. And I don't know. Yeah, there's units, but it didn't ask for units. So centimeters, but there's no. It didn't ask. And that was worth 2 points. 1 for the setup, 1 for the number. Everybody good with part B? All right, part C, the laser is farthest to the right at t equals 1.253. We want to find the x coordinate of that rightmost position. Well, that means that we're going to need to integrate just dx dt from 0 to 1.253. And then we'll add our initial condition to it, but our initial condition was 0. So we don't really need to worry about that. So part C should just be the integral from 0 to 1.253 of our dx dt, which I don't remember what it was, so I'm just going to write dx dt. And that came out to be 2.932. Pretty easy as well, I hope.
Very cool.
Yeah. 1 for the setup and 1 for the answer, or 1 for the integrand. Actually, the whole integral, the limits as well. And then part D, it says, what is the difference between the y coordinates of the laser's highest position and lowest position for t equals 0 to t equals 3.1? Well, in order to figure that out, we need to figure out at what t values it hits its highest position and its lowest position. And so the only time that it could do that is when dy dt, when the velocity in the y direction hits 0. So we will set dy dt equal to 0 for cosine of 2.5t, I think it was. And that happens at 2 different t values. One of them was 0.628319, and the other one was 1.884956. And then the other times that it could be at its lowest or highest points would also be at the endpoints of our interval, since it's a closed interval. So we'll say t equals 0 and t equals 3.1. And so we just need to figure out which one of those is the highest and which one of those is the lowest. Well, at t equals 0, we know that the y value is 0 because it says it starts at the origin. And then we'll figure out all the rest. So we'll integrate from 0 to 0.628319, the dy dt dt. And that one came out to be 1.6. If we integrate 0 to 1.884956. That one came out to be negative 1.6. And if you integrate 0 to 3.1, that one came out to be 1.591358. So it looks like the highest point was 1.6, the lowest point was negative 1.6. 1.6 minus negative 1.6 is 3.2. And they gave you 4 points for that one. 1 point for setting dy dt equal to 0. 1 point for finding the two critical values. 1 point for setting up an integral properly somewhere in here, and 1 point for an answer with some work to show that you tested all of these other points. Any questions there on part D?
No.
All right. Everybody feels okay about those?